Now, thanks again for the host to CTU to host this symposium, and also thanks to RGC for funding our project. So I would take this opportunity to share the overview of our project and the result and etc. And this is the outline of my presentation. And I start with mentioning our team, and then I will go through the objectives, and then I will talk about how the specific tests we focus on, and with the examples, specific research, including the active research projects, how we collaborate with industry and other institutions, and a summary of our output. So this summarizes the different institutions within Hong Kong. The major institution involved in this project is CTU, which we host the project, and then the other institutions include Hong Kong U, and Chinese U, and Poly U. And there are overseas institutions who are involved as well. And within Hong Kong, and there are other organizations, industry, government organizations are involved. And we also have an advisory board which involves some other institutions as well as industry, local or overseas. We have a very big team. Some of them actually join us in the later period, and others actually they were no longer involved due to some reasons. And we have distribution, even distribution of senior faculty, junior faculty, and including associate professor and assistant professor. And we also have an advisory board team, which on the right-hand side here, which include industry, as well as some experts in academia from overseas and also locally. And here is the research objectives summarized in this graph. And our main focus in this research are really on assuring safety and reliability, avoiding and managing disruption, and ensuring operation efficiency. And it's all around before and after the disruption, okay? Before the disruption or incident accident, of course, we would like to avoid this from happening. And we also want to ensure the safety and operation efficiency. But in case if this cannot be avoided, such as due to natural disaster and some other thing, we will focus on how we manage this disruption, and how do we mitigate it, and how do we reduce the impact. And these are we call that research thrust areas. We divide our major research tasks into three major research thrust areas. The first one we call the engineering asset management system, okay? And that will be on really about safe reliability modeling and prognostic and health and system health management. And the second research thrust area will be on the crowd management, scheduling, and hazard in the stations. And the third topic will be on disruption management, which will include demand, capacity, and how do we logistic, etc. And finally, all this will be integrated together for testing and validations. Now, among these 3 or 4 thrust areas, we will line up, as I mentioned, we have a very big team. We have, in order to manage such a big team with very different disciplines, and we have to divide the team into sub-team, okay? Then we will identify sub-team leaders for each topic, okay? And so we have a well-management plan to manage such a huge team so that we will have successful research collaborations. And on the right-hand side, again, is our advisory board, where we have people from industry, government, as well as from academia. So they will be providing advice, comments. We will be meeting with them every year and solicit their comments. We will be sending documents for them to comment and provide advice. And also, in addition to our team and advisory board, we also will line up the project and motivate our research and connect it with the industrial problem. So for that purposes, we also, for each of these research thrust area, we will line up with different companies. Of course, the local company, MTR, will be involved in almost all projects, but for other industry, which I will talk about specifically, we also collaborate with other industry outside Hong Kong, in Taiwan, in China, or even overseas. So among these 3 or 4 research thrust areas, they also interrelated. Okay, we wanted them to interact with each other. Here is a couple of examples. This example is about health monitoring, reliability engineering. In this topic, and we have our own equipment to collect data from our lab. And also, we also have lab data from other institutions' lab, which I will talk about later. And we also have data from the field, which will be the actual operating of the trains during the operations. And we have all these different sources of data. With this data, we'll be developing methodologies, okay? And then we will validate this methodology with all this real data. And this will be mainly focusing on health monitoring, reliability engineering, but they are related to other research thrust area, such as the demand capacity, as well as integration or the crowd management. Here is another example. It's more related to RTA2, which is about scheduling and crowd management. Here we have both high-speed rail safety issue, we have the scheduling issue, and we also have the issue about evacuation during the disruption. So there are different pieces, and we are focusing on, and many of these pieces are related to what we call the people movement. We develop simulation models, we develop other data mining analytic model for modeling and predicting this. And they are related to other RTA, such as RTA1, RTA3, and RTA4. And here, let me get into some specific how we are doing this, okay? We collaborate with, collaboration with industry is a major part of our research. So we work with MTR as what we call a 2-way collaboration. We have 3-way collaboration, which means that we work with the industry through and other academic institutions outside Hong Kong, such as the Southwest Jiao Tong University, such as the National Taiwan University. I'll get into more specific as we move forward. So here, of course, MTR is local company. We have the most collaboration. At least these are the 7 we mentioned. We also have additional smaller ones. And I will just mention a few of them. One of them is about crowd management. This project is related to how we make use of the CCTV to develop some data mining or data analytic algorithm to automatically count the number of passengers in the platform. And this will help us to manage the platform, to estimate the waiting time, and improve the management of the company. Here, this is another one about health monitoring of the component in the train, including the rail, okay, the bolt, and the clipper. Again, the same way, they make use of the camera mounted under the train to take pictures. So this is an ongoing project. We are developing algorithms and deep learning algorithms to automatically identify the objects, its components, and also to tell if there are problems with this component. And we also have a project on the escalator. We think they told us they have several thousand escalators. They are all reaching the stage where they have to decide either they have to refurbish the escalator or replace them. Okay, so we have developed an ITF project for this to continue this project. It's still ongoing. And outside Hong Kong, we work with the CRRC, this the Seaform company, which they manufacture the trains. So we did this through the South Jiao Tong, the State TLab and South Jiao Tong, Southwest Jiao Tong University. And we are doing some bearing for diagnostics. And we also work with the Southwest Jiao Tong University on, they are installing sensors, over 100 sensors on every new train model. So they collect a huge amount of data. So we are working with them to make use of this field. These are called field data because they are being collected while the train is in operation. We are trying to relate this field data on the vibration sensor, some other sensor, to the health condition of the component so that we could monitor the health condition, make decision about what we should do. This is the detail of the algorithm we developed. I don't have time to go through that. We also work with the Shenzhen Metro company through the Southwest Jiao Tong University again. This time, we are not looking at the structure of the component. Rather, we look at the passenger flow. Okay, we make use of the smart card data, they call it AFC data, which will have the detailed record of all the passengers, where they board the train, where they leave the train, and all the detail. With this data, we are able to do a lot of research in terms of forecasting, photo link, identification, etc. We also have a project with Taipei, which is through the Taipei Metro Taiwan University. Okay, and so this is when we signed a three-way collaboration with the vice president of Taipei Metro. And one of the projects with Taipei Metro is really about monitoring the health condition of the track. So they were actually using a fixed maintenance plan where they will replace the track every fixed period of time. What we are doing with them, but they're also measuring the wear of the track. So what we are doing is making use of the data, building the reliability model to predict the health condition of the track so that they can make better decisions. Another project with Beijing Jiao Tong is really about using again CCTV to detect unexpected objects in the trains to avoid any safety or some other issue. This is another ongoing project. We also try to collaborate with Tsinghua. We pay visit to them. They also pay visit to us. There is a big research center in Tsinghua University. And we visit Japan. They are the best, well-rated technical research institute. We still yet have to identify a collaboration project with them, but we learn about how the research in rail, how the leading research in rail is going on in Japan. Now, let me just summarize with all these specific projects, and I'll summarize what is the research outcome. And we are running this annual workshop 16, 17, and 18. And last year we planned it, but it did not happen because of social unrest, and we did it this year. And for the disruption of the research, we have applied to get a 1-year extension. So our research is still active, have more than 1 year to go. And we are also involved in this Asia Pacific Rail Expo, which is a much bigger scale, which includes 100 exhibitors and 2,500 attendees. They're running an academic symposium. We were involved and organized several projects within this expo. Because what we have done, then other countries learn about our research. The Seoul Metro company contacted us. They wanted to learn from us. So we have hosted 3 independent one-day workshops for Seoul Metro for them to learn from our research results. We're also running student presentation. And this is the summary up to middle of this year. And this is what the number of students, PhD students we have trained. These are the publications we have produced. And just to summarize, and our experience that this large project will actually create a really nice interdisciplinary research platform and opportunity for the students and young and senior researchers, which normally you do not get in the smaller project. And also it allows us to connect our research with the industry and learn about the problem, make use of the data to really validate the model we develop. And also we have take the opportunity to train a lot of intern and a lot of students and young faculty. And for technology transfer, we have established a number of ITF projects through the research we are doing with industry. So this is still going on. And finally, and then we are holding conferences and publications. And to end this presentation, I wanted to tell you that we are running another panel session just next week about, if you're interested, you're welcome to join. So I will stop here and I will be happy to answer any question there will be.
We received a couple of questions already. So let me just read that up. The Professor Cui, it is very interesting to see the AI component developed to help ensure the safety of metro system operations. It will be a future direction. So could you please share a little bit of your view about how these technologies will save the cost and boost the efficiency in the railway system operations and maintenance?
Thank you for the question. And that's basically, there's no doubt that the AI will play a very big role. I mean, as you can see from the projects I mentioned. So there are already two projects, right? One is about the crowd counting, okay? The passenger counting and crowd management, okay? So that is one that, in fact, that is still going on, and there will be a lot of future for that, and when a better algorithm will develop, and right now it's already real time, and sometimes they're not able to really count a certain number of people when it's too crowded or when the angle is not good. But with more cameras and better algorithm will develop, so then they could do even better. So then with that more accurate information, there are a lot of things they could do, including safety, even safety, and of course efficiency, etc. The other direction is really about the health monitoring. So we already talked about the mounting the camera under the train to do the inspection of the component on the track, okay? And so there again, you need the real-time AI algorithm, okay, to be able to detect, okay, the object and tell if there are problems with that. And one direction I did not talk enough about is really about the monitoring, other than underneath the train, monitoring and the overall, you know that especially high-speed train, there's so many miles of track. So then how do you monitor the space over the track? Because they worry that something will fall into the track. They mount a CCTV surveillance camera there, but they don't have good algorithm to detect object. They cannot tell is something that may cause them danger, or some of them may be okay. Okay, so that will be one direction. And another direction I have not talked about is that, and we're working with the Beijing Jiaotong University, that they're using drone machines. They're actually setting drone to actually, right now what I said earlier was that they're mounting the camera under the train. The quality of the image may not be very good because the train is running very fast. So the other alternative is they're sending drone to take pictures or even take video on the track as well. So that is another ongoing project in taking those pictures. So we have to develop AI algorithms to really try to monitor the health condition. So I'm sure this will continue to grow as technology, sensor technology, camera technology, video technology are being developed. Thank you.
Okay, so one question, I will just read it here from Ken Chung. Which countries have the best safety and reliability record on high-speed rail? Maybe just a quick answer.
Okay, okay, it's actually a challenging question. Even it was a very interesting question, right? even before we started the project, this thing came up already during the interview, okay? And they think that, okay, it was interesting, right? So one of the reviewers in the panel asked, well, it seems Japan, this was 5 years ago, right? They said, it seems Japan has the best safety record. Back then, and China was not that well developed. This was 5 years ago, right? They said, well, Japan has the best record. Why don't we just learn from Japan? Why do we have to do our own research here? So that was a challenging question. But of course, I mean, it's not easy to compare, or you cannot copy directly from other countries' system, because there's a culture, there is the environment, there are many factors that contribute to the safety of the system. So that's why Hong Kong also will be a good environment to develop our own research to help both the local system, both the local metro system, the high-speed rail system. But we also expect that our research result is expandable, is transformable to other countries with the modification of the local culture. So with such a long answer that, I mean, I don't have a short answer to say that, it's because which country has the best record, because even the safety record, there are different metrics to measure that, okay? And even you have the same metrics, I was told that in different countries, they may have different way of implementing the same metrics. So that's why it's very difficult. Hong Kong has a very, very good record. But when other countries sometimes evaluate Hong Kong's record, they don't think Hong Kong has the best record. So that's what the story we have heard about.
Let me just jump to another question that might be relevant to researchers in Hong Kong. You mentioned that there are some ITF projects from this SIM-based research project. So could you elaborate a little bit more, and what could this team and the other teams do to actually make use of the SIM-based research project to generate more practical and useful research for industry?
So there are a number of ITF projects related to our team-based that I know of. One is really about the escalator I mentioned earlier. That the company, MTR company, truly believe that condition health monitoring is very critical for their assets, because MTR has very large, very expensive assets, and they are also coming to the stage where they need to make a lot of financial decisions. Okay, and they don't want to make the same decision for all assets because they know that some assets may be have better health than the others. So that's why they want to use the sensor to monitor the health condition. Okay, so the escalator was the one where they, because of the success of other projects, we're working with them and they want us to help them. So we just, I think that was funded by the company are responsible for buying the equipment, installing the sensor, and our team will be doing all the data modeling for that, okay? And the other potential ITF will be on scheduling. And I also learned that some of the team members have an ITF project on scheduling and all the management, scheduling management for the metro system. So there may be others I do not know of. Yeah.
Yeah, I think we have time for just one question, and I will try to combine a couple of questions from the chat box. You are also involved in the other STEM-based project. So what knowledge can be transferred, especially using deep learning methods in rail system, PHM for rails, and also to humans in future?
Yeah, so it's an interesting question. This health monitoring the health condition of a system, the concept nowadays has, I mean, people believe that the same concept can be applied to the human, which is not surprising, except human is because we are talking about a complex system. Human is almost by far is the most complex systems, okay? And so nowadays their research, that's why Professor Tan's research earlier we talked about, we also collaborate with them. How do we use the sensor, okay, to collect data about the human's health, and we will monitor the human's health, individual human's health, such as elderly or some other adults' health, so that we wanted to detect the potential health risk before that develop to be hazard. So that is the same concept. So we are working with Professor Tan on that. But I also want to mention, though, as I mentioned earlier, that because this project, because of the interruption of the social unrest, we have extended the project for 1 more year. So for those people who are interested in this project, I wanted to let them know that our project is still going on. Professor C will be the new PC for this project. I will be involved, and we'll continue to run this project. So if you cannot answer your question right now, you could keep your question, you could send it to us, and we will continue to communicate with you. We would love to work and collaborate with other people who are interested in the area of research.